Hi everybody and welcome back. Let us evaluate our dataset. At first we import matplotlib.pyplot_splt and emgorg.augmenters as IAA. Next we define the augmentation pipeline by using IAA.sequential. As mentioned in the introductory lecture, we use random affines consisting of random scales in the range from 0.85 to 1.15 and heavy rotations from -45 to 45 degrees. Besides affine operations, we use elastic transformations to locally displace some pixels. We are now ready to create our dataset. At first we define the root path to all files by creating a path object to the pre-processed training files. Next we can finally define our dataset by calling cardiac dataset, to which we pass the root path and our augmentation pipeline. Let us conclude this lecture by visualizing a sample slice with the corresponding segmentation mask. To make sure that the augmentation works properly, we access the same slice multiple times and visualize the augmented image and mask. To do so, we use a 3x3 plt.subplots object with a figure size of 9x9. Next, we use the double-nested for loop in the range of 3 to access the individual axis objects. Above all, we use our dataset to grab a slice and corresponding segmentation mask. In my case, index 1 is a slice that shows the left atrium. Depending on your computer, you might need to change this index. Next, we use numpy.ma.masked_where to mask all pixels that are 0 in our segmentation mask. We can now access our current axis object to visualize our extracted slice. Note that as we added the channel dimension above, we need to get rid of it. As usual, let's use the bone color map. After that, we access the same axis object once more to plot the segmentation mask. We also have to get rid of the channel dimension. Alright, let's have a look at the result. Perfect! In this figure, we can see that despite having different augmentations, the segmentation mask fits every time. Therefore, we can state for sure that our dataset works. To use our cardiac dataset in a training notebook, we copy the code together with the necessary imports to a separate Python file. Let's scroll above and at first copy our necessary imports and next the cardiac dataset class. We rename this file to dataset.py and save it. In the next lecture, we are going to build the UNet together. Thanks and see you soon.